Hi, I'm Gordon Waite. I'm about to start work on a 22-inch f4 telescope mirror. This is the first of a pair of 22-inch f4 mirrors that I'm making for a binoscope project. Giant pair 22-inch binoculars. 22 inches of telescope for each eye. Very cool. Well, anyway, I received these blanks from Newport. They're pre-generated to the f4 curve. And when I did the inspection on them, a couple things pop right out. I'll try to show them to you here. The first one is that this mirror has quite a little bit of swirl marks left on it from the generation process. I think you can see the little swirls there. Focuses on them. And those are actually pretty common. You find those almost all the time on mirrors because the mirror is generated with a big diamond cup tool on a big turntable, so you oftentimes have the swirlies. The issue is the depth of them and how the machine pulls off in the end. Now the other issue about this mirror is that I can feel in the center of it that there's a belly button there. And I can feel there's a defect there, but I can't really tell what it is. And as I move out, I can't really tell the magnitude of the problem. So I have to find out really what's going on with this mirror before I start in earnest. So the technique that I use is to coat the surface of this mirror with a felt tip. And I start in the beginning in the center here, and I'm just going to coat over it. I can already see there's a little center defect there. So the important part is to blacken out the center and then to blacken out the edge. So I'm going to turn the turntable on here, slow it down a little bit, and put some marks around the edge. Now what I'm going to do is to start the grinding process with kind of a fine abrasive to begin with and do it for just a short period of time and see what kind of pattern I get left over from this Sharpie test. Now a lot of times when you're making small mirrors, people have heard of the Sharpie test and you use it to see if you've got a spherical surface. And this is basically the same idea, just that I'm using the Sharpie early in the process to make an evaluation of the initial condition of the mirror. This is the best kind of art. Now, you don't have to get the whole thing black, you just want to have enough Sharpie on it so that you can tell where the grinding takes place when you start things up here. Okay, now we'll let that dry for just a little bit. I've already got the tool ready. I've made up a 16.5-inch tool with ceramic tile and dental plaster. And I chose 16.5 inches because it's 75% of the diameter of this 22-inch mirror. 75% of 22 inches, 16.5 inches. I'm going to use fixed post grinding where I set up an offset with the tool on top of the mirror hanging over the edge, spin it up at high speed with abrasive in there and quite a little bit of weight on it. And that's the setup that I'll use to do the grinding of this mirror. Now the trick with binoscope obviously is the two mirrors have to be as close to identical as possible. So the trick will be to set up a common focal length. And basically I'll more or less grind one out and then measure it, and I'll probably just try to shoot for as close to the f4 number as possible. With the 22-inch, f4 would be 176 inches. So that'll kind of be what I shoot for. And then the second one I'll shoot for the same thing, but in the end I'll adjust the second one to match the first one. So that'll be the strategy. Now our Sharpie test here, felt tip marker test, it's not coming up, so that looks like it's ready to go. Now what I'm going to do is use 25 micron abrasive. And 25 is kind of where you would start if you had an absolutely perfect generation job. With the diamond generator, you can use quite a fine abrasive like that to begin. But if there are any serious defects in the surface, you have to go with a more aggressive abrasive, a larger abrasive. So I'll squirt some water on here to moisten it up. Now normally I don't do this, but I'm going to go ahead and kind of spread this around a little bit by hand. For the Sharpie test here, I want it to kind of start out well distributed. Okay, and then the tool goes on top. See if I can give you a look here. This is the tile tool, And it's about 1/8 inch ceramic tile embedded in dental plaster, 16.5 inches in diameter. Put this down on there. And I've pre-set up my overhang here to give me about a 2-inch overhang, I guess, maybe slightly more than that. And at this point it's not real important, but I start with that overhang to, it's kind of a neutral position. About 15% of the tool will give you a fairly neutral grinding position. You refine that later on. So we've got this in place. Let's just grind for a little bit now. Now 25 micron doesn't grind very fast, but with high speed and everything, it will do the job for us. Because basically all I want to see is where it grinds away and where, if anywhere, it doesn't grind away. Now I can still see a little bit of ink on there, although it's getting thinner already. I'm running the turntable right now at about 60 RPMs, and there's nothing causing the top tool to rotate except for the friction between the two pieces. And with the overhang off the back, the differential gives us the grinding motion. So as a point on the tool goes around, it goes from fairly, short radius inside there all the way out to the edge and beyond. And this configuration allows you to grind to quite an excellent spherical surface without having to do any stroking like on a traditional machine at all. Very fast. I can put as much weight on here as I want. Typically I'll grind with 50 pounds or more on a mirror of this size, with 50 pounds on top of the tool to get maximum speed. With silicon carbide abrasive, the more pressure you put on it, the faster it grinds. So you want to get weight on there and do a good job. Okay, we're getting pretty close here. I can see that a lot of the ink has disappeared on the mirror. So let's call it good and see what we have. Okay. I'm just going to take a paper towel and wipe off the swarf and the remaining abrasive here. And we'll see what we have. Very, very interesting surface here. Now what I'm hoping you can see is we have a very unique shape here. Let's fan this off a little bit and maybe it'll stick out even a little better. Get this surface dry and everything should become obvious. Okay, and I think one more paper towel. Maybe we can remove a little of the white. Okay, so what do we have here? We see right here on the mirror, this center defect is pretty strange looking. There's a big arc here, a little belly button right there, and it arcs back out here. And this whole area in here hasn't been touched by the grinding. And you can feel it with your finger, like I said. So it turns out that this is a low spot on the mirror. It's below the normal surface. And that's fairly deep. I can feel that with my finger, and that's going to take a little bit of effort to grind that out. Matter of fact, I can feel that whole interface right there, the transition over it, with my finger. Now the other thing to notice is that this area of the mirror here is clear. So this all has good contact with the tool. But then there's this edge over here has ink on it again. So I've got a low area over here. Now that's fairly interesting. This is a unique generation job. And what it means is that I won't be able to start this mirror with 25 micron abrasive. Instead, I'm going to have to back up. And from the feeling and the look of this, I think I'm going to go to 280 silicon carbide. I hate to go deeper, more coarse than 280 because the coarser abrasive will get subsurface fractures. With 280 I'll get some, but it's easier to get out. I can go directly from 280 to 25 micron with just a little extra time on the 25 micron. So I see this pattern I've got. To get rid of that, we have to start with a little coarser abrasive. What I'll do is a wet or two at 280, stop and check again, make sure that I'm making progress. If I'm not making progress on it, then I back up to say 120, which would be kind of my worst case scenario. But if things are going well, I'll just give it the time on 280 until I've got a good sphere and I've taken care of all these generation problems.